Very good morning, my dear students and friends. Today we discuss about Unit 3 Non-Conventional Energy, subject of Energy Technology. The topic is wind energy. It is a very biggest topic. As for the our syllabus, wind energy and then types of windmill, types of wind rotor, Dairy's rotor and the Graviton rotor, wind electric power generation, wind power, what are the policy and then what are the steps we can take and then future scope of wind energy in India and then economic of wind farm. All the topic we discussed today. This is a topic already we discussed. So wind energy is nothing but the wind is a simple air in motion. It is caused by the uneven heating of the earth surface by the sun. So we can use solar energy with the help of solar energy. It is possible to develop wind energy. Since the earth's surface is made very different type of land, water, it should be absorb the sun heat at a different rate. Yes, definitely in the center of earth it should be absorb more heat as compared than end of the pole. Energy derived from the wind velocity is a wind energy. Wind energy is obtained with the help of windmill. Yeah, there should be converted wind energy into the electrical energy. It is the required minimum speed of wind speed 10 km per hour. It should be considered to useful the working of windmill for the agriculture purpose. Along the sea, coastal and hill area, windmill are like most successful in Karnataka, Maharashtra and Gujarat. But the farming of windmill at a place is very difficult to carry out the goods on that place. Wind power or wind energy is use of wind to provide the mechanical power through the wind turbine to turn the electrical generator and traditionally to the other work like a milling or pumping purpose. Wind power is a sustainable and renewable energy. Yes, is definitely sustainable. It should be available entire lifespan and is a much smaller impact on the environment as compared than banning a fossil fuel. What is the smaller impact? While the wind turbine is rotating, it is possible to create dry surface in front of the windmill. As compared than the effect of fossil fuel is very small. The wind energy varies from one time to time and then one place to place. Is some of the negative disadvantages. We cannot able to place any places on the surface. The kinetic energy of wind is converted to useful shaft powered by the windmill. It is the working principle of windmill. Look at the windmill. In Tamil Nadu, we are the second largest Muppandal wind farm. It should be generate 1,500 megawatt. China is a Gansu wind farm. It should be around 8,000. Look at the first and the second. It's a very huge difference. India is the most promising country to implement many causes in the wind farm. Tamil Nadu is the most leading places in the farming of the wind energy in India. Few factors would be affecting wind farming: the latitude, the height and altitude, geographical location, and then scale of the hour, month of or year. What do you mean by scale of hour, month of year? How much air is available, the concerned velocity per hour, per month, per year. It is a main factor to farming the wind energy. It is a main component windmill, air system and coupling generator. It's along with some controller. The controller is given to guide the windmill according to the position of wind direction and then power grid. It's the external we connected through some electrical cable. Already we discussed about introduction of this subject, wind energy conversion. The kinetic energy of wind should be converted mechanical energy in the through blade and some mechanical arrangement. The generator should be connected to the wind rotor. It automatically generate electrical power. It is useful for our external purpose. So wind turbine. In the three rotor designed windmill, the windmill are used to convert the kinetic energy of air into the mechanical energy. That means the energy of motion of the wheel is due to wind into the mechanical energy. It is connected to the generator, is converted to the electrical energy. Generator is generally a basic principle. It should be converted mechanical energy into the electrical energy. To other word, the wind turbine windmill is converted to the wind energy into the electrical energy. It's same meaning of the both words. Next we discuss about the types of windmill. Generally the types of windmill, there's a size and then output power, location we can classify. The minimum classification is axis, horizontal and then vertical axis windmill. The size of the wind machine variety we can use. A small turbine used to power a single home or a single business purpose. We can use the capacity more than 100 kilowatt. The large turbine are often grouped together to form a wind farm to provide power to the electrical grid. The electrical grid is connected to our local power supply. We can use that type of energy to us. It's a horizontal axis and then vertical axis. Horizontal axis, the axis is parallel to the surfaces. Vertical axis windmill, the rotation of windmill right angle to the surfaces. Types of windmill. There is a Savonius or S type. Its another name is called Gravident rotor, and then Darius windmill. The S type is a low wind velocity application. Suppose it have high velocity, we can use Darius windmill. And then horizontal axis windmill is further classified single plate, double plate, multi plate, and then bicycle multi-plate type is another name is called sail type. The vertical axis machine is simple in design as compared to the horizontal axis. The axis of rotation of vertical axis wind turbine is a vertical to the ground. It is a right angle to the ground surface. Is almost perpendicular to the wind direction. Yes, it's definitely perpendicular to the wind direction. This turbine can receive wind from any direction. Suppose there is not possible to horizontal axis windmill is not able to receive many direction. Hence, complicated yaw design can be eliminated because the horizontal windmill have yaw rotor. It have the complicated as compared than here is a simple design. It's already we told that it's a simple design. The generator and gearbox system we can place at bottom side. So it is a stability and other is a very simple. There is a maintenance of the turbine can be done at the ground level. It is a very good advantages. We can maintenance to be made by the ground surfaces. The major disadvantage of vertical machines, the turbine are usually not self-starting. It have the additional some starting purposes. It is a vertical axis milling machine. Windmill. Another is a S-type windmill. It's a low wind velocity windmill. The velocity is compared than Gravident is very low. The shape of the plate is formed with the S shape, so it's called the S-type windmill. Look at the diagram. It's a S-type. The whole box will be split and then placed opposite direction. That's called the form of S-type. One is the convex, another the concave. Concave should be converted to the wind energy into the mechanical energy. convex is be divert the wind power. The draft you can use a high wind velocity. It has some other advantages. They support the blade in such a way they minimize the bending stresses in the normal operation. The stress is very dangerous to break down the blade. This type of windmill we can minimize the stresses. It requires less surface area as compared than S type. Is machine, the blade is curved and then attached to the hub of the vertical shaft. Both ends form a cage like a structure. The blade look like a egg beater. It look like a egg beater. And drives rotor have the three symmetrical aerofoil blade, both ends of which are attached to the vertical shaft. The force of the blade to the rotation is a pure torsion should be converted to the mechanical energy. You look at this Darius windmill. We have here three aerofoil should be connected to the vertical shaft. On the bottom side we have the generator. The generator is always placed on the ground side. And then we go to the horizontal axis windmill. The horizontal axis windmill, the wind turbine have their axis rotation horizontal to the ground, almost parallel to the wind stroke. Most of the commercial wind turbine using this type of horizontal axis windmill. Disadvantage is a low cut speed and it is easy furling. Furling is nothing but bending or some unavoidable braking is only possible with the high velocity. In general, the slow relative high power coefficient, it have high coefficient of in the form of the power. All the component, the gearbox, gear reduction, generator are placed on the top of the windmill. It should be more complex and expensive. And then depending on number of blade, horizontal axis is classified single, double, 3 and multi-bladed. The modern wind turbine, the velocity of blade is 6 times to the wind velocity. We can design the blade should be withstand 6 times as compared than wind velocity. It's a single blade. It's a single blade extremely high, long length is around 60 meters. Mounted on the hub, the larger blade root bending movement may be occur due to the lower shadow, gravity and the sudden shifts of the wind direction. To reduce the rotor cost, use low cost counterweight is recommended for balancing along the balancing blade centrifugally. Let's look at the diagram. Balancing blade is placed in the top side. We can use a composite blade. It's a single blade horizontal axis type. And then we go to the two type. Generally, two type blade is not a very commercial and then not economical. It is fixed and continuously flexed by the unsteady aerodynamic, gravitational and then inertia